So let's start with Bn students. So I can say here Bn is nothing but 1 upon L 0 to 2L f of x multiplies to sine of n pi x divided by L dx. So we can write here 1 divided by 3 by 2, 0 to 3, f of x is 1 minus 2x. This comes to be sine of 2n pi x divided by 3 after substituting value of L as 3 by 2. Now let's write Bn as 2 by 3 and let's write integration. This comes to be 1 minus 2x. Further, I can say integration of 1 minus 2x and integration of sine comes to be minus of cos of 2n pi x divided by 3, and this whole gets divided by 2n pi divided by 3 minus differentiation of 1 minus 2x is minus 2. Integration of this comes to be minus of sine 2n pi x divided by 3 and whole gets divided by 4n square pi square divided by 9, where limits are 0 to 3. So now once you substitute limits, that comes to be, there is 2 by 3 constant lying outside. So let's substitute 3 students. So when you substitute 3 here, this comes 1 minus 6, that comes to be minus 5. This I can write as 3 divided by 2n pi. There is already one more minus, so let's write minus here, and this comes to be 3 and 3 gets cancelled, cos 2n pi is 1. So there are 3 minus, but before that let's substitute 3 here. 3 and 3 gets cancelled, sin 2n pi is 0, so I can write minus 0. Minus, let's substitute lower limit. When you substitute lower limit, that comes to be 1 minus 0 and minus 3 divided by 2n pi. Cos 0 is 1, sin 0 is 0, so that I can write as minus 0. Let's solve it, students. So Bn comes to be 2 by 3, minus and minus becomes plus, 15 divided by 2n pi, minus and minus becomes plus 3 divided by 2n pi, which you can write as 2 by 3, 18 divided by 2n pi. This comes to be 6, 2 and 2 gets cancelled. Finally, I can write 6 divided by n pi. So therefore, students, we can write f of x as a0, I got it, that is 2 plus an is 0, so I'll be not writing an, I'll be directly writing bn. Bn is 6 upon n pi, so 6 divided by n pi into sine of n pi x divided by L, which is 3 by 2. So we can say f of x comes to be 2 plus summation n equal to 1 to infinity 6 divided by n pi sine of 2n pi x divided by 3. So that comes to be our Fourier series. Now the next sum is, which we are going to start in the same paper, is question number 3a, that is obtain Fourier series expansion for the function f of x is equal to 1 plus 2x divided by pi. The range is from minus pi to 0, and 1 minus 2x divided by pi range is from 0 to pi. So students, I request you, similar sum you can refer the same sum in my module video, that is, I'll just mention here, refer in video of module, so that is FS 13 part 1. The same sum I have solved there.